You can design a perfect static architecture diagram, map out every microservice, and document every database constraint. But that initial blueprint only tells you what to build. It lies about how the system survives in production. Planning for true enterprise scale requires a shift in how you execute your development roadmap. You cannot simply provision more servers and expect stability. The central engineering challenge is bridging the gap between an initial deployment that supports 1,000 early adopters and an enterprise load that crushes the system with 1,000,000 concurrent users. When applications collapse at that scale, the root cause is rarely a broken user feature. The failure stems from a structural vulnerability in what we call the minimum viable architecture, or MVA. To survive the jump to 1,000,000 users, an engineering roadmap must map stress and time, not just features. The industry standard is to race toward a minimum viable product, or MVP. This approach relentlessly optimizes for early, visible feature delivery to show immediate progress to stakeholders, prioritizing top-level user capabilities without establishing the underlying architectural support creates a top-heavy, inherently fragile environment. The user interface might look complete, but the backend lacks the structure to handle friction. For enterprise roadmaps, there is a critical alternative, the minimum viable architecture. This chart breaks down the MVA hierarchy. We focus on the bottom two layers, system structure and foundational properties, proving a broad base must exist before mission effects are built. We define this phase as day zero operations, marking the transition to dynamic execution. Day zero requires engineering teams to provision the golden paths, automated continuous integration and delivery pipelines, unified observability logging, and strict zero-trust security protocols. These infrastructure elements must be fully operational before a single end user is ever permitted to log into the system. An MVA remains stable under intense user load precisely because this architectural bedrock absorbs the friction of scaling. As the user count climbs from 1,000 to 1,000,000, the broad base prevents the entire stack from tipping over. Establishing the MVA on day zero is the non-negotiable prerequisite for enterprise survival. Once the bedrock is laid, the timeline shifts from the planning of day zero to the active execution of day one. Day one operations are governed by a single unyielding rule. Deployment is not release. Pushing new code to a live environment and exposing it to 100% of your user base simultaneously carries an unacceptable risk profile. The ultimate risk mitigation strategy for moving code into production safely is dark launching. Using feature flags and proxy sidecars, engineers route a 5% shadow stream of real traffic through the new system nodes. This executes entirely invisible to the end user. The engineering value of this 5% sample is immense. It subjects the new architecture to unpredictable, real-world user behavior rather than sterile, synthetic test data. Decoupling the physical deployment of code from the public release of that code allows engineers to test in production without causing production-level casualties. So, what exactly is the engineering team measuring during this dark launch window?
The focus here is purely on non-functional requirements, the invisible forces that determine if a system crashes when thousands of users interact with it simultaneously. At scale, the non-functional requirements that matter are specific telemetry data, P95 latency, error rates holding tightly below 0.5%, and concurrent transaction throughput. Testing against these exact percentiles, like ensuring 95% of requests finish within the latency limit, guarantees your service-level agreements are met under real load. If any non-functional requirement breaches its assigned threshold during the dark launch, an automated response triggers. The shadow traffic stream automatically severs and reroutes back to the stable legacy environment. This automated kill switch is what makes the dark launch safe. The experiment ends in milliseconds, long before live users experience the latency. The telemetry data from that failed test is then fed directly back to the developers, providing the exact logs needed to patch the minimum viable architecture. Traffic routing is only expanded beyond that initial 5% after all non-functional requirements hold stable across extended steady-state periods. Ultimately, the dark launch serves as the architectural stress test, confirming the system's ability to survive in production. Day 0 and Day 1 are brief, time-bounded events. Once stabilized, the timeline pivots to Day 2, stretching into an infinite operational lifespan. Day 2 is the ongoing, relentless phase of maintenance, performance monitoring, and system optimization. This is the classic blind spot of modern DevOps. Teams will invest months building complex delivery pipelines for day one, but completely neglect structured governance for day two. Neglecting this phase inevitably results in configuration drift. Over the span of months, manual patches and untracked changes cause the system to silently degrade. Modern cloud architecture offers a double-edged sword, the ability to scale horizontally with almost unlimited elasticity. The dangerous financial corollary to that elasticity is that unlimited cloud scaling translates directly into unlimited operational cost. Technical scalability is completely useless if the system becomes too expensive for the business to keep running. To prevent runaway cloud waste, organizations must introduce FinOps as a strict Day 2 governance framework. Intent-based FinOps policies act as a financial governor. As server nodes spin up to meet traffic spikes, a synchronized cost meter rises. When demand drops, automation instantly terminates idle resources, dropping the cost back to baseline. Cost reclamation must be an automated Day 2 process. Relying on manual developer intervention to spin down servers guarantees wasted spend. This interconnected journey maps the true lifespan of a system. Day 0 establishes the minimum viable architecture. Day 1 executes dark launching, ensuring the architecture can endure stringent non-functional requirements in production. And Day 2 utilizes FinOps and unified observability to ensure the system remains economically and technically viable forever. An MVA-driven roadmap provides the empirical proof that a system can withstand the pressures of the real world.